Good morning, everybody. Welcome. First of all, thank you to Mobile Europe for inviting me to speak. And I'm going to talk about cloud, a little bit about BT. We're the number one network in the UK. We're also number one global network for businesses. We operate network in over 150 countries. We have 5G network here in the UK, 4G as well. We're the only operator to have grown our footprint in the last year. And we're building out FTTP through our OpenReach division. And really, a core part of that is how we connect everything together. And cloud, for us, network, what we call network cloud, is at the heart of our kind of new core network. But we're also looking at FWA, not using 5G or 4G, because I think that would bankrupt you, as some operators are finding out. But we're looking at interesting new fixed wireless access technologies that leverage Wi-Fi technology, and also working with our fantastic partner OneWeb on using satellite to connect people. So we're really here to connect everyone and make them part of the digital ecosystem and make them part of the internet community. And you know, to show the scale, the reason I show this slide is to show the scale of what we need to build to make cloud work for us. You know, we are, you know, this year our network peaked at 28 terabits. We have 30 million homes connected to a super vast platform up to 80 meg. We have 7.6 million premises connected past with FTTP, sorry, not connected with FTTP. And we're building fiber to 25 million homes by 2026. So significant investment. And our 5G geographic coverage by 2028 will be at 90%. And today we've covered half the population in the UK with 5G rollout. And it's not, but it's also, and this is really important, it's really easy to build technology that customers don't like. And that is, you know, that can be the answer, particularly strategic in a competitive market. So it's not only about building cloud or building networks, it's about building them and ensuring customers love them. So we are the number one network as measured by not just root metrics, but pretty much every single benchmark. You know, we've led through our EE division, and on fixed network, you know, I think one of the great things about the pandemic was as people started to realize the value of fixed broadband. And we've done a lot of work to ensure that customers love the service. And that's really important as you start to think about how 5G in the cloud can help customers in the future. So let's get on to network cloud. So the kind of genesis for network cloud actually started in 2012 when we hosted the Olympics. There's 3 or 4 big takeaways that we had from running the Olympic network here in the UK. It seems, and that was 10 years ago, which seems insane, but it just shows you how the development of mature technology, how long it can actually take sometimes. But you know, here we have our core network, and we have what we call BT network cloud infrastructure across 12 locations, over 2,000 servers, and we're running multiple workloads on it. The key one that we're running now is our cloud native mobile core, which is all the Gs plus standalone. We use Juniper's SDN controller for instant network availability. The whole thing is automated. We leverage code to build things in this platform. We get an unbelievable amount of rich telemetry, actually almost too rich. At the moment, we're probably not taking advantage of all that's there. And the key thing, the word I'm going to use, and this is really important in cloud, is simple, keeping it simple. You know, if you kind of pick up a book on the cloud or how to build something in the cloud, you can see how complex it gets very quickly. So for us, we've kind of driven towards cloud native and containers as opposed to VNFs, which really in a multi-tenant or service provider environment, we don't think really scales. But the benefit of this is, we've got our end-to-end platform for hosting all the applications we need as a telco in a secure way, in a location where we know where they are, and under our control. And I think it's an interesting stat that I'll share with you, but through the pandemic, our public switch telephone network, the old telephone network, had a better uptime than the public cloud. And that's really crucial for us in telecommunications. Our industry is the backstop for society. When things go wrong, people look to the network or leverage the network to fix them. And that means that when things go wrong, we can't. And it's a crucially important topic that as we build out our networks, as we change from old school networks to the latest in IP and segment routing and everything that we're doing to leverage new technology, new optics, new types of fiber, even quantum, we need to really remember that the network always has to be there. And I think in the last few years, I'm not sure we've really been thinking that way. So we control the reliability. We control the scale. We can scale up, down. We can scale it, at the same way that the cloud can. And we're ready for some of the new technologies that are coming down the road: network slicing, cloud-based RAN, and many other communication services that our customers will need. And it's not to say that the public cloud doesn't have a part to play. Many of our customers are in the public cloud, so we also have to connect to the public cloud and service what's required there. And again, with our kind of standard container, it's really simple for us to do that. What's crucial about this, though, is in telco, we kind of have to admit something. We kind of have to admit that actually building cloud infrastructure was not an expertise that we had, and it's something that we've had to learn. And in BT, we've put a huge amount of effort into training and upscaling our teams, and every part from field engineers that have to go and swap cards or swap disks, to the network operations team that have to fix things, to the network design engineers who are used to working with platforms from Cisco or Juniper or Nokia. They've got to learn a whole set of new skills. Some of them have it, they've got Unix or Linux backgrounds. They understand BIOS. They understand the PCI architecture, but it's really important that you invest in that, because if you think about what's happened in industry, we've seen a lot of telcos try to build this infrastructure and not be successful. And the reason for that is the skills. It's not the technology. This technology is not the easiest technology. It's not that difficult, but it's super difficult. It's like a quiz show. It's easy if you know the answer. If you know how this technology works and you've got the right engineering team, it's easy to build this. And it wasn't easy for us. We had many challenges. But where does that take us? So people say, NVIDIA, we've been doing that for donkey's years. And I'm like, well, really? It's kind of we kind of took a step that was based on what people had done in IT, and a lot of folks say, hey, we're the whole network's being IT-ified, or we're going to leverage more and more IT, and I kind of chuckle at that, because people who say that clearly don't understand a single thing about networks. So if you ever hear anyone saying that, tell them that Neil McRae said, well, you clearly don't know anything about networks, because in the network, we have so many different things that separate us from what an Oracle database or a SAP platform does. We've got state, we've got protocols, we've got different technologies, we've got latency, we've got routing, we've got scheduling. There's so many different things that we have in the network. To say that you can just lift it and stick it on an IT box is pretty horrific thing to say, in my view. And as you can see, I get quite animated about it. But the one thing that we're really excited about is what cloud native can give us. And we actually started looking at this in BT Labs, working with a platform called Mythos, which was kind of like Kubernetes. It's an Apache project, where you can scale based on, not based on virtual machines, but you can scale based on disk, memory, CPU. And we really thought, that feels like the sort of approach that we need in telco. So we're really, our cloud 5G platform is cloud native. We're leveraging Kubernetes. There are other platforms out there that we're also looking at, but ultimately allows us to really harness the value of cloud, the scalability, the extensibility, and really, to some extent, we're not quite there yet, abstract the hardware, but there's still much more to do on that. And here it says, this slide, which I borrowed from my friends at Nokia. I really like the way that they flag cloud native. We talk about kind of abstracted infrastructure. If anyone thinks that we've done that in cloud for telco services, again, they need to think again, because if you try to run DPDK or you try to deliver something that needs acceleration, hello Open RAN, there's no abstraction. Let's be really clear about that. So where does that take us? It takes us to network as a service. There's I think a discussion on this throughout this week, where we've been trying to get to network as a service, and part of the reason we haven't is because we haven't had the underlying fundamentals right. If you're going to do network as a service and someone asks you for, they make an API call, you can't not deliver it. And with previous NFV type solutions, you'd run out of resources, you'd run out of capability. So we're really looking, and we have this up and running today for some services where customers can talk straight to the network and build what they need to build. We have this in our voice solutions. We've even built it for the PSTN, not to offer to customers really, but to make it easier for us to operate. But we're kind of building this as a requirement in any network capability, and we're building this into our main global and UK networks over the next couple of years as we roll out our BT Network Cloud, and we have the capability to do that. But the great thing about this is we give customers control, we give developers control. If they need a path from London to Glasgow, they can log in, use an API, and boom, they've got a high availability path between those two locations. If we want to use a controller to do something, perhaps in the RAN or in Wi-Fi, we can leverage APIs to make things happen, to improve things, and also this just doesn't sit in our space. We've built it into the public clouds so that where we offer customer services, we can use all the same capability. Underpinning that, telemetry. If you're not doing telemetry and you're still using SNMP, I suggest you go take a long shower and come out and get into the world of telemetry. Telemetry is the most important change in telco in the last 10 years, in my view. It gives you an ability to really understand what's going on in networks, and it gives you an ability to automate effectively. And we've got this big AI buzzword. Everyone's excited about that, and it's great, but actually telemetry is what makes it real. And all the big network operators are kind of there now, particularly Nokia and Juniper, who've done an outstanding job on delivering us telemetry. But we've got to go out there and make it happen. So SNMP and BT is a banned thing. People have to come and ask me for special permission if they want to use SNMP, because it's just not for the future. In a real-time world, we can't use non-real-time technologies. But there's still some challenges with cloud native. I'm not going to say that it's all perfect, because it's not. We have a lot of people that say, "Hey, we're cloud native," and we install it, and it's like, not really. And basically, what we want to do is run applications as if they were cattle. We don't want to have to specifically manage things, or as people like to say, have pets in the infrastructure. It should just stand up, and we use different tools to herd the cattle, not lots of speciality to keep your pets happy. Vendors are still too much trying to interfere in some aspects of the underlying infrastructure layer without being really clear about it. And we're not storing state independent of the application. So when it breaks, and this is the big difference in telco that I mentioned, if it breaks, we can't repair it, or we can't repair it easily. We've got to restart everything, and that's clearly not an option. Partial scaling. So, we haven't and this is a maturity thing, and I'm not overly worried about this, but this is some reality where, we don't have true microservice level applications or functions, and therefore you can't scale it well. And then that also then leads to they're not really abstracted from the infrastructure. And because of that, you can't automate it, right? So you end up with partial automation. And again, I think this is a maturity issue. I think over time, suddenly going from one direction to say, oh, we're going to be cloud native and run microservices everywhere, that's going to take time, but we see everyone moving in that direction. Again, I'd shout out Nokia and Ericsson, who are doing an outstanding job in this space. Juniper too, where they're really pushing to really be microservices led. I won't spend too much time on the slide, but kind of some of the things that we have to think about as we go cloud native and we build our own clouds is, there's Kubernetes is a tiny piece of the puzzle. It's a really important part of the puzzle, but there's a whole lot of other stuff you need to do: security, hardening, compliance, signing images, how you're managing clusters, how you're managing API gateways, patch management. I mean, that whole thing, we need to think about that differently. And then being able to see what's going on, especially if you're using, something like DPDK, which makes it quite difficult. It's really important that you can observe what's happening in the network, because you need to know if it's working or not, really. And then the kind of interface and service mesh, how we really get to a standard set of infrastructure. Again, I think we're still a long way off that, and I'm part of my brain says, will we ever really get to a standard set of infrastructure, or will we always have specialization? There's an interesting paper that CSAIL at MIT put out about building silicon where silicon's going to head more towards application demand rather than generic demand. And having this platform really puts us in a great place for cloud. Sorry, not for cloud, for edge. We've got a platform that we can take to anywhere on our network. We can actually build it on customer prem, or actually we can containerize it and stick it in the public cloud and say, hey, we can give you whatever capability that you need. And we're really well placed here in the UK. We have 100 core network sites, very high bandwidth, and we've got 1,000 tier one exchanges that are close to our 5G network and close to our FTTP head ends. So that allows us to be able to offer that. We can partner, with the public cloud guys, and we do this today. We work with Google, Amazon, and Microsoft, for customer type services. But we're not about to put, the core network into the into the public cloud, because frankly, it just isn't good enough. And public cloud is so expensive. I mean, this is the thing. We have this one of the kind of great questions I have in telco right now. We have a huge amount of effort on Open RAN because we think it's going to save us money, but then we're building it into the cloud, public cloud, where it's going to cost us more money, and we're going to lose control over the underlying economics. For me, that just does not make sense. So look, we love the public cloud guys. Google deliver a massive amount of value for us in analytics. Amazon, we run all of our IT, and Amazon, they do an epic job. And Teams, we do Operator Connect with Microsoft, and our customers love it. But those applications fit that infrastructure. So, we want to work more with those guys to bring them the value of what we understand in telcos, reliability and cost optimization. And then with that edge platform, all these 5G applications suddenly become much more doable. And I won't go through the slide in detail, but it allows us to leverage compute in a way to help industry become more automated and become generate more value. Everything from planning roads to helping the NHS manage hospitals, training with AR, VR. All of these things are enabled by having this cloud expertise that you can take to customers and say, hey, we're not just connecting you. We've got this compute capability that you can leverage. And that's it from me. I hopefully didn't overrun. I saw there's one question from Federico that I'll answer. So, Federico, I think mentioning the Italian market is probably not the strongest situation given kind of where the Italian market is right now and what's going on there. But what I will say is I think if you want to really manage the service that you give to customers, having the end-to-end infrastructure and service together gives you a unique advantage in your ability, one, to control the costs, two, to control the quality, and three, to control the delivery. And we are very much focused on that as a strategy at BT, and we think it gives us a significant advantage. Annie.
Okay, so I had a few things. One thing, Neil, is talking about edge, and we've chatted about this a few times.
Yeah.
I think very often when operators are talking about edge, they're talking about are the more focused on connectivity at the edge and low latency and all those parameters. And you just kind of touched on this in your last slide. But I think surely one of the things they're going to need at the edge is the compute.
100%.
So could you just talk a little bit more about your thinking around that and what it kind of brings to the party?
Absolutely. Let me just step back to the slide. And actually, there's another slide I wish I had because for that question. But so if you think about it, we are take something like faster engineer aircraft inspections, right? Now, some people who fly a lot like me probably think, crikey, I hope they're doing a great job of inspecting aircraft, right? But imagine a world where we're given tools to those engineers where everything that they're doing can be captured in super high resolution video. So the inspection or the manufacture of the plane is captured in really great video. The process they use, the tools they use, the spare parts that they install, the things that they do are captured in high-res video. Trying to carry all of that video back to the public cloud and then process it, analyze it, and then come back with results is really difficult. If I could, and we're not talking about HD video, we're talking about 8K video here. And potentially three-dimensional video as well. If I can do that on-prem and offer them a camera as a service or a video analytics as a service capability, then I need that compute to be on site to make it the most effective application. Now, again, there are certain industries where that would definitely be needed. There's others where actually, HD video would be good enough and we can use the cloud for that. But if you're trying to do any significant real-time video analysis, anything above HD, having the compute local makes a massive difference. And I'll give you an example of that, right? If you get your phone out and take a 4K video and upload it to YouTube, and then upload the 1K video and see how long it takes YouTube to process the 4K video versus the HD video. It's just harder. There's more to do. But if you've got that local, one, you've got low latency. Two, you can instantly kind of look at the video or move it around, do things with it, and then you can run it through an analytics engine locally to say, well, this, engineer number 5, we noticed that as he was servicing the 737, that he did something different from all the other 737s that he's done before. Is that something unique to this? Is it something we need to learn? Is it something we need to understand? So anomaly detection with video, and we see many organizations using video for anomaly detection in their production line, Annie, and that needs compute on site for two reasons. One, the network doesn't break that often, but when it does, they've got to keep working. So having compute locally allows them to have some redundancy. And two, just the sheer scale of the data can be significant. And then also three, many companies still concerned about security of their own IP. By keeping it on premise, that gives them some comfort. It's probably not true in the bigger scheme of things, but it does matter to many organizations.
Okay, and sometimes, Neil, I think the perception is you've been quite an outspoken critic of Open RAN. Now, my understanding is that you're not per se, and actually BT's got skin in the game. You have worked on Open RAN.
I'm a critic of anything that doesn't work for the customer, Annie. Right, and okay. I think in our industry, and I'm guilty of this too, sometimes we get so excited about the technology we forget about the customer, right? And in Open RAN, I really think that's the case, where we're so focused on saving money in CapEx, which, don't get me wrong, is important, but we lost sight of actually, well, if we're not managing customers or what their needs are, how this would really help. And that's where things like the RIC come into play. So whilst and also people make bold statements like, oh, we've made this much more, supply chain resilient. We've expanded, there's more vendors, there's more people that we can leverage. And actually, when you look at the bare bones of what's there, actually the same components from the same manufacturers, probably made in the same factory, Annie, in China or in Mexico. It turns out actually there's not a lot of diversity there. So, I want to see more silicon designers building more silicon options. I want to see more software options. I would love to see a 100% open source Open RAN platform. We don't have that today. So whilst open, we also must remember Open RAN is effectively the open standard that allows different Open RAN components to talk to each other. Those components in themselves are proprietary. And I think we forget about that often too. So, but ultimately for me, it's when I look at my customers and what they're doing in the network, I will deploy any technology that gives them a better experience, a more reliable experience, and makes them more sticky for us at BT. And we've got a massive Open RAN lab. We've had it for a long time because we've been doing longer term research on ultra MIMO and technologies like that. But when I hear the world's going to change, and I look at it underlying, and it isn't really, I feel that it's important that we flag that and say, actually, what are we trying to do? So we are not technology religious in any sense, other than it must work, it must be reliable, customers must love it, and we must make money out of it.
Just before we go to the second question we've got from our audience, we touched on applications in silicon, and you said, I think, citing an MIT paper, that it looks like applications and silicon are going to become more application specific. I mean, we've got ASICs in some contexts already. Could you just say a little more about what you feel about that?
Yeah, so if you think of, and I'll share a link to the paper on the chat if anyone's interested. So I'm a kind of a silicon geek. You see the pinball machines in the background. I'm an electronics geek. When I was kind of four-year-old, I was if I wasn't writing code, I was burning myself with a soldering iron. So, and it's just kind of a geek type thing that I've got. I'm really fascinated by how we've built integrated circuits. As you know, I'm a big space nut, and that's where a lot of the silicon development started. So. What we're seeing with Moore's law is it's actually getting harder to achieve the things that Moore's law sent out, which is and a friend of mine, Basil Alwyn, who was at Nokia, runs Tarana Networks. He calls it Moore's observation, and which is I think over a period of time we double the number of transistors in a chipset, and I think it's getting harder to do that when you look at it especially when you're looking at it from a generic point of view, where you're trying to capture the things on a chip that are going to serve a really wide base of customers. Be it telcos, be it people playing video games, be it people just using their laptop for Excel, whatever that happens to be, it's getting harder to add value. And I think if you look at most of the code out there in the last, 5 years, it's written in kind of languages that are not CPU friendly. So I'm a C programmer by trade. It's kind of what I grew up on. I still try to write most of what I do in C, which kind of scares the hell out of a lot of people. But I know that I'm going to get a really well executed application if I do that. We have a lot more kind of what I call simplified languages that do great things, but they cause us to use an immense amount of CPU. And what this paper points out is that there's two things. One, if we optimize the silicon for specific use cases, Moore's law will go on for a long time. But also on the flip side, if we get better at writing software, Moore's law will also go on for a long time. And those platforms that are using these kind of less efficient programming languages, they build, people who work on that build things expecting the next chipset to give them a performance boost, and actually the likelihood is that isn't going to happen. And looking at how you've written your code, looking at the algorithms you use and optimizing them is going to become much more important in the future. And it's something that I've had a long belief in, and actually seeing this paper talk about this was really exciting. As I say, I'll share the link. So, and we see it today. I mean, we see some of this today. So we have optimized CPUs going into smartphones. In Open RAN, it's not all software. We got accelerators, very unique to Open RAN, going into some of the bigger radios. We've got digital signal processors and optical. One of the optical, coherent optical, as you know, is one of the most CPU intensive workloads that we have in the network. So we see some of this in telco already, but I think we're going to see it in many other spaces across the technology landscape, not just in telco, but everywhere. We're going to see this more optimized silicon is my take, and kind of what this paper points towards.
So that's interesting, Neil, because I don't know anything about coding, but I do know that when you're writing as a journalist, it takes a lot longer to write shorter. And it sounds like the same applies.
It's similar, yeah. I mean, just look, we have so many amazing programmers in the world today that are creating amazing applications, but we've abstracted all the kind of hardware and all the details so much that we don't understand. The person programming perhaps doesn't understand the impact of what they're writing. And if you think of so if you write something really badly, the CPU is making up for how you've written it by processing it more. There's a number of things happening. One, the CPU is getting hot.
I was going to say, you're just literally burning through its capacity, right?
Yeah, and you're using more energy, you're using more cooling. And in a world where energy and cooling are becoming ever more important, I'm not sure that the way that we've historically created some of these applications is the future. And I think we need to get smarter about that. And the good news is if we are smart about it, there's a massive prize for us, both in CPU cycles and energy and many other things. And that's something that we've got in mind at BT also.
Okay, Neil, thank you for that. I do feel that we should answer this question, which is, could you give some examples about telecom services that can benefit from elasticity and any best practices on decomposing legacy services for cloud native? We're already running a tad late. So
let me try and answer them very quickly. So Luke, we're on Zoom right now. There's nothing more elastic than a conference where you might have 50 people turn up, you might have 100 people turn up. We see the same in telephony, where there are days where we're scaling up some of our telephony services or some of our conference services, and we're scaling them down. Things like signaling. If you have a problem on the network and you need to have a lot of reattach, typically in historical 4G networks, that was really difficult. Today we can scale up the signaling engine, get everybody attached, and very quickly, and life goes on, as opposed to the kind of signaling storms that we used to have in the 4G network. And then finally, best practice. That's a really good question. I don't know if we've got enough experience to have a best practice other than testing. Just test everything, and have a really, don't assume in your testing that something's going to do. Don't make assumptions in testing. Assume nothing, test everything. That's the only probably best practice advice I can give today. I think that's something maybe to come back maybe next year or the year after and give a view on what we've learned in this process. I hope that's answered your question.
Neil, I enjoyed that immensely. Thank you as always. Always a pleasure. No doubt we'll speak soon.
Great. Thanks everyone for joining. I hope you enjoyed the presentation, and you got a lot of great stuff coming up today, including Viraj from our team on Edge later on today. It's going to be an exciting panel, I think. I think that's going to be quite an exciting panel. Thank you very much, Neil. Bye-bye.